The most difficult task for writing a recursive method is to divide the problem into smaller problems. Means we need to write a recurrency relationship for the problem. For example, Fibonacci number n is equal m times n minus 1, n minus 2, n minus 3 until 1 for any integer n larger than 0. So we can represent factorial n with n times factorial n minus 1. That is called recurrency relationship. We recursively define the original problem with smaller identical problems. So we can write a recursive definition of factorial as factorial n equal n times factorial n minus 1. And there will be a base case that if n equals 0, factorial 1 is 1. Then we get following formula. Based on the recurrency relationship, we can easily translate it into a method. The recurrency relationship can be written with recursive step. The base case can be written with base case. So we can write factorial n recursive method as return type should be integer. The method name we call FACT factorial. For all the recursive method, we need a parameter. The parameter is used to control the size of the problem. Inside, we can see the base case. If n equals 0, return 1, and else part represents the recursive method code. So if n is not equal 1 or larger than 0, we just return n times FACT n minus 1. We can check if the factorial method satisfies the 4 criteria for recursive method. First, there is recursive method call itself. Second one, each recursive call solves smaller problem. Number 3, there is base case. If n equals 0, return 1. Number 4, the base case can be reached since each time the recursive call solves n minus 1 problem and then n minus 2, n minus 3. Eventually, the parameter can be equal 0. Let's see another example, Fibonacci number. We know that Fibonacci number for each number in the sequence is the sum of previous two numbers except first two numbers. The first two numbers, Fibonacci number 0 is equal 0. Fibonacci number 1 is equal 1. So the sequence of Fibonacci number is 0, 1, 1, and then 2, 3, 5, 8, 13, 21, 34. So all other Fibonacci numbers are defined as the sum of previous two numbers. Based on the definition of Fibonacci number, we can write the recurrency formula as Fibonacci number n equal Fibonacci number n minus 1 plus Fibonacci number n minus 2. That is general case. And then we can think about the special case or special cases. For Fibonacci number, the special cases, if n equal 1 or 2, the Fibonacci number would be 0 or 1 according to the definition. Based on the recurrency relation, we can easily write recursive method for Fibonacci number. The general case could be written for the recursive method call, and the base case can be written with base case. As you can see, the FIB method accepts an integer value n as parameter. Return type will be integer because Fibonacci number are integer. So if n smaller equal 2, return 1, else return FIB n minus 1 plus FIB n minus 2. You can see each time the parameter will be decreased. And also Fibonacci number recursive method has two recursive calls inside. That is called multiple recursive. Recursion can be divided into several groups. For Fibonacci number or factorial number recursive method, those are direct recursion. Means what? If a method calls self directly, there are other indirect recursion. When a method calls another method that eventually calls the original method, that is called indirect recursion. If two methods call each other, that is called mutual recursion.